All right, this is the free response for version A. Multiply and simplify, we need to do a window pane. These are binomial times a binomial. So 10 square root of x and 5 negative 2 square root of x. So 10 times 5 is 50. Then this is 5 square root of x. All right, and outside by outside, negative 2 times 10, that's negative 20 square root of x. All right, and this last one, negative 2 times 1 is negative 2. Square root of x times square root of x is x. Okay, a lot of you got square root of x squared, but that reduces to x. Combine your like terms, and you've got 50. Negative 20 plus 5 is negative 15 square root of x minus 2x. All right, you could have written that in a different order. As long as all three of those terms are there, you're good. All right, solve this equation. So first, isolate the radical. It already is. Step 2, cancel the radical. So you have to square both sides. All right, the tricky part here is when you square the right side of the equation, you have to do a window pane. It's x plus 1 times x plus 1. So that's x and 1, so x squared, x, and 1. So x squared plus 2x plus 1, combining your like terms here. All right, since this is a quadratic equation with an x squared, we need to set it equal to 0. So I'm going to subtract 5x and subtract 11 from both sides. 0 equals x squared minus 3x minus 10. Okay, most quadratic equations can be factored. So let's see if we can do this. X times x. All right, 5 times 2, negative 5 times positive 2. Okay, negative 5 times positive 2 is negative 10. And negative 5 plus 2 is negative 3. So that's where I came up with those numbers. And then the answers are actually what would make each one of these parentheses 0. So positive 5 would make that one 0, and negative 2 would make that one 0. Okay, except there's one more step you have to do. Remember, we have to plug them back into the original problem and make sure they work. All right, so for this, we're going to use our calculator. All right, so I have the square root of 5 times 5 plus 11. Okay, that's 6. And then if I plug 5 in over here, 5 plus 1, that's 6. So 5 works. All right, let's try negative 2. All right, so I have the square root of 5 times negative 2 plus 11. Okay, that's 1. And if I plug negative 2 in here, negative 2 plus 1 is negative 1, not positive 1. So negative 2 is actually an extraneous solution. So the only acceptable answer on this one would be x equals 5. All right, number 15, you want to convert this rational exponent into a radical as your first step. So denominator makes it a cube root of x minus 12. Okay, we need to isolate our radical, so I'm going to divide by 4 first. That's negative 4. We need to cancel out our radical now, so I need to cube both sides. Put that in parentheses. So x minus 12 equals negative 64. And then we need to add 12. All right, let's plug it back in, make sure it works. So I've got 4 parentheses, negative 52 minus 12, close the parentheses, to the power of 1/3. And it equals negative 16, just like I wanted it to. All right, for this last one, you need to determine if they're inverses. So you got to do two things, f of g of x, and if this comes out like we want it to, then we have to do g of f of x. All right, so f of g of x, I'm going to take the entire g function and plug it in for x here. So 1/2 times 2x plus 10 minus 5. Okay, distribute the 1/2. 1/2 times 2 cancels out. 1/2 times 10 is 5. And 5 minus 5, those cancel, leaving me with x. That's what you want to get. If it reduces down to x, then you're on the right track for them to be inverses. So let's check g of f of x. If this one also works, then we're in business. So I'm going to take the f, plug it in for x here. So that'll look like this. Okay, distribute your 2. 2 times 1/2 cancels out. 2 times -5 is -10. Plus 10, those cancel, leaving you with x. Since they both simplify down to x, the answer is yes. These are inverses.